In this problem, we will be given two different scenarios for each problem. We will be finding the numeric answer for this question in scenario A, finding the numeric answer in this situation in scenario B. Then we'll be asked if the numeric answers we just found to A and B are equal, either yes or no. And after that, we are to give a reason why the answer was yes or no, and it would be one of the following reasons. It'll either be because addition is commutative or that addition is not commutative, or if the problem involves subtraction, the answer will either be that subtraction is commutative or subtraction is not commutative. And it turns out that two of these statements is false always, and two statements are always true, and this problem is to show which two are true and which two are false. So here's an example that illustrates this. Scenario A, I have that Hector eats an apple, so I'm going to write the number 1 to indicate that he has eaten one apple. He then eats 2 more apples, so that we would add 2 more. And the question is, how many has he eaten total? So he ate an apple and then he ate 2 more, means total he ate 3 apples. So our numeric answer to scenario A is 3. Then looking at scenario B, he does it in the reverse order. Instead of eating an apple and then 2 apples, he eats 2 apples first, and then he eats 1 more. How many apples has he eaten this time? Well, he's eaten 3 again. So it doesn't matter if Hector eats 1 apple and then 2 more, or eats 2 apples and then 1 more. Total, he will have eaten 3 apples regardless of the order in which you add the two numbers. And the reason this is true is that addition is always commutative. So for example, if I move over to Math AS, for our scenarios, the answer would be that yes, they are equal. And the reason is that addition is commutative, and that's always true. Addition is always commutative. I'd like to do one more example using subtraction. In this example, we have that Nima is 10 feet above sea level. So let me write the number 10. And she walks down a hill, and her altitude drops 15 feet. So if her position was 10 feet above sea level and it drops 15, we would have to subtract 15 to determine her new position relative to sea level. So not that you'd have to draw this, but suppose this was sea level and she is 10 feet above it. She would be dropping 10 feet to get to sea level, but since she went down a total of 15 feet, going down 10 would not be enough. You'd have to go down 5 more to have dropped 15, and that would put you at a position of 5 feet below sea level, which would be -5. So when you calculate 10, subtract 15, this does give her new position, and that's the question. What is her position relative to sea level after the drop of 15 feet? And the answer would be -5. In the second scenario, we have that Nima starts out 15 feet above sea level, and then she walks down the hill, but this time she only drops down 10 feet, so we would subtract 10 feet from her altitude. And what is her position relative to sea level? Well, she was 15 feet above sea level, she went down 10, so she would be at a position of 5. So this example illustrates the difference between doing 10 subtract 15 and 15 subtract 10, where the two scenarios, if you compare them, can be thought of as switching the two numbers around, or switching the order in which you are subtracting the numbers. And notice that you do not get the same result. This is -5 and that is a +5. In fact, whenever you switch the order of subtraction, you always get one number being opposite in sign relative to the other, so they're never equal. So in Math AS, you would say that the results were not equal, and the reason is that subtraction is never commutative.